Okay, in this video, I'm going to discuss the method of section in trust analysis. Uh, the previous one, which is the method of joins, or the first method, it is most effective when the forces in all the members of a trust are to be determined. If, however, the force in only one member or the forces in a very few members are desired, another method, which is the method of sections, is more efficient. In the method of sections, a part of the truss is isolated on a free body diagram so that it exposes the forces to be computed. Uh, and if the free body diagram for the isolated portion contains three unknowns, all of them can usually be computed from the three available equilibrium equations. So, but if the number of unknowns exceeds three, one or more of the unknowns must be found by analyzing a different part of the truss. So if you are skillful in writing and solving equilibrium equations, the only challenge in using the method of sections is selecting a convenient part of the truss for the free body diagram. Pero the usual practice is once mukat ka og seksyon, ang imong analyze na part is katong part having lesser number of forces. Para gamay ra imong ina-consider when you sa mga forces or when you sa mga moments. But just make sure that there are only three unknowns because we only have three conditions of equilibrium. Uh, in practice, the portion of the truss to be utilized is obtained by passing a section through three members of the truss. Tulo ra gyud. Okay, although na cases na upat, kanang K-truss, it's a special case, pero na technique na. One of which, sa tulo ka members na makat, one of which is the desired member. You draw a line which divides the truss into two completely separate parts, left and right, but does not intersect more than three members. So either of the two portions of the truss obtained after the intersected members have been removed can then be used as a free body. So bisan asa ana pwede nimo himuon na free body. Pero as I have said, ang usual nga gagabuhaton is katong part ng lesser number of forces ang pilion. So example kini na i-trust tapos na ang pangitaon either sa BD, BE o CA diri ka mag-cut. And then either you analyze the left part or the right part. So kung sa left part ka, mas dali siya because di na kinahanglan i-solve pa nimo ang reactions. Whereas kung sa right part ka, kuhaon pa nimo ang reaction. So, mas madugay ka. So, para mas dali, left side i-analyze. Mas convenient gamiton ang left compared sa right. Okay na. So, three unknowns, and then we have three equations for equilibrium, ma-solve siya, di ba? Pero ang intent ani method of section is to apply a condition if possible, you only have one unknown sa equation. And like in this one, if you will use a measure of force along x, wala kay ma-solve because you have three unknowns. If BD, if BA because there are horizontal and vertical components, then if CA. So you have three unknowns, di ba? So useless kung magamit ka og summation of force along the horizontal. Kaya wala mo kayo ma-solve, ba? So ang usual nga buhatan na is sum up moment para na kay only one unknown, di ba? So sao man na. So, if you will solve for one force, dito ka magsama pag-moment sa point of intersection sa other two forces. Like for this one, if you want to solve for CE, FCE, magsama pag-moment sa point of intersection sa FBD and FBE, which is joint B. So kung dili ka mag-moment sa B, ang moment anin duha, zero man, kay mga gyud siya joint B. So ang ano nimo, FCE na lang, di ba? Similarly, if you want to solve for FBD, dito ka magsama pag-moment sa point of intersection sa FBE and FCE, which is joint E. Okay, kung dili ka mag-moment sa E, zero man sa ninduha, and you can solve for FBD. Pero sa kung ingunani imong trust na ang duha ka members horizontal, and if you want to solve for BE, you cannot use summation of moment because the two forces BD and BE are parallel. Therefore, you can never find a point of intersection sa duha ka forces. That's the time that you will use summation of force along the vertical. Kay horizontal man sa duha, so wala siya vertical component, di ba? So when you sum up force along the vertical, your only unknown is FBE. Atong iyang y coordinate. So inaan lang. Okay. So mula na ang buhaton ninyo kung mag-solve mo o mag-analyze mo og trust using method of sections. Okay, let us solve a sample problem. A Warren Bridge truss is loaded as shown. Determine the force in members EG, FG, and FH. So first, you need to solve for the reactions. So you sum up moment either at joint A or joint K. Sige, sa A lang ta. Counterclockwise moment, positive. So RK assumed to be upward. So moment niya is counterclockwise times distance. 12.5 times 5, that's 62.5. And then 6,000 clockwise times distance, another 6,000 times distance, 25. Naki-RK na 36. Positive, therefore upward. And then summation of force along the vertical, you can solve for RA. RA is equal to 8,400. So after this, ready na rin ka mag-solve. So we are going to solve for the force in members EG, FG, and FH. So mag-cut kag section passing through the three members like this. Ayan na. So it now depends on you which part you are going to analyze. Okay. So pinaka-convenient actually is ang right side because you only deal with one force, RK lang. Whereas sa left side ka, you have RA and you have the 6,000 pound na forces. Pero for this illustration, we are going to analyze how we are going to consider the left part. Okay. So this one, and you have the reaction at A, 8-4, and then you have the three forces, EG, FG, and FH. Okay. So let us start with member EG. So again, if you want to solve for EG, sum up kag moment sa point of intersection sa other two forces, FG and FH. So that would be joint F. So you sum up moment at F equal to 0 na. Sige lang. So counterclockwise positive. So EG counterclockwise times distance niya 15. And then plus ang 6,000 plus 6,000 minus 8 for them. Mao ni ang equation. It's very simple. It's just force times distance. Just make sure that the perpendicular distance is correct. Like for 8, 4, the perpendicular distance to point F or joint F is this. 12.5 times 2 plus 6.25, and that's 31.25. So after this, simplify. Force of EG is 7,500 pounds. Positive, huh? And we assumed all the forces to be tensile and a positive, therefore EG is in tension. Uh, ano lang? Okay, next. Member FH. Dire. So sa FH, you will sum up moment sa intersection sa other two forces, FG and EG, which is joint G. So dili ka mag-moment sa G, and you have this equation. FH is clockwise and negative sa distance 15. 6,000 counterclockwise, the distance is 12.5. Another 6,000, distance is 25. And then minus 8 for the distance is 37.5. Simplify. You have the force of FH equal to negative 6,000. Therefore, in compression ang force or ang member FH. And for FJ, that's the time that you'll use summation of force Y. So you need the vertical component of FG. So first, get the slope of this member. So like this one, ang slope niya is 15 vertical over 6.25 horizontal. So if you divide 15 divided by 6.25, ang fraction na makuha nimo is 12 over 5. So mo na ang slope mo. 12 vertical is to 5 horizontal. And by Pythagorean theorem, the hypotenuse is 13. So, ang vertical component niya based on our previous discussion on how to get components is vertical, that's 12 over 13. Ang horizontal is 5 over 13. So when you sum up force sa Y, katong 12 over 13 ka. Like this one. So upward, 8,4 minus 6,000. Downward man minus FFG niya, component niya, a factor niya. 12 over 13. And FG is negative 3, 9. Therefore, it is in compression. So, iunahin lang ang paggamit sa method of sections. One equation, one unknown. Yeah. Another problem. Determine the force in members BD, BE, and CE of the Gambrel roof truss shown. State whether each member is in tension or compression. Now, if you look at this truss, ang geometry is symmetrical. The loading is also symmetrical. So by inspection or by symmetry, the reaction at A is equal to the reaction at H. So all you have to do is add all the forces, divide it by 2. And the reaction is equal to 1,200 pounds at A, 1,200 pounds at H. So when we solve for the force in members BD, BD, BE, and CE, then we're going to cut a section passing through the three members, like this one. Uh, and again, let us analyze the left side. Okay. So you have 1, 2, and then the forces BD, BE, and CE. Okay. So let us start with member BD. So, okay. You solve for the force of member BD, sum up ka og moment sa intersection anin duha, BE and CE, which is joint E. Okay? So, sum up ka og dili ka sa E. Now, incline ang force sa BD. So, you need to get the horizontal and vertical component. So, kung sa ni mga slope ani. So, sa may slope ani yung BD or kini DF, pareha raman sila. I-divide nimo vertical over horizontal. So, vertical, 2 feet and 4 inches. I-divide nimo og 8 feet. Just convert it to inches para ma-cancel ang unit. And you will get, okay, horizontal and vertical. So, you will get this one, 7 over 24, no? 2 feet and 4 inches. If you want to convert, if you will convert it to inches, that's 28, di ba? 2 times 12, 24, 28 inches. While 8 feet, converted to inches is 96. 8 times 12, 96. So, 28 divided by 96 will be reduced to 7 over 24. And by Pythagorean theorem, this is a special triangle. The hypotenuse is 25. Ano? And for the other inclined members, this one, ang slope niya is 6 over 8, no? Or simply 3/4. Sorry, 3/4. 3 is to 4, rather. 3 is to 4. Okay. So, this component, this force is equal to FBD times 24 over 25. While this one is FBD 7 over 25. So, ano siya? Kana. 24 over 25 niya, 7 over 25. So, let us have a moment at E. And this one is clockwise. Clockwise. Yeah, counterclockwise. Counterclockwise. And then another clockwise. So, you have 5 moments. So, this one, 24 over 5, the distance is 6. And then 7 over 25, the distance is 8. And so on. Okay, if BD is equal to negative 1, 2. Therefore, member BD is in compression. Okay, next, member BE. Ano For member BE, sum up moment sa intersection sa BD and CE. Now, CE will pass through joint A. But member BD will not pass through joint A. Di ang iyang line of action, no? So you need to extend this one. Extend sa another iyang point of intersection. Like this one. Okay. Dere. Let's denote it as point P. So we need to solve for this distance. Kaya dayon ta mag-moment. So this one would be the moment arm of 1, 2, and 300. Let's denote it as X. So how do we solve for X? We will use ratio and proportion. Bali, similar triangle. So we will extend this one and then form the triangle. Yeah, and vertical is to horizontal. Vertical is to horizontal. So extend na to. Ana. And you get this, we get this distance. And then 8 raman eh, Pareha ni 8. Dire lang. It's 6 feet plus 2 feet and 4 inches. Yun. So by ratio proportion, we have this one. 6 over 8 plus x equals 8 feet plus 4 over 12. Converted ang inches to feet. 8 plus 4 over 12 is to 16 plus x. And you have this x, 88 over 7. Pwede na. So, sum up moment at P. Okay, 0 na nindo ha. Kanila, yon. Get the components of this. Of course, the data. So that you will not get confused sa distance. So, and since ang slope na to is 3:4, hypotenuse would be 5, then this component will be 3 over 5 or 0.6, and this one 4 over 5.8. Pwede na. Summation of moments sa P, we have 5 forces. 1, 2, 3, 4, 5. Okay. So, 0.6, ang distance is 8 plus x. 8 plus x. While sa 0.8 f, ang distance niya is 6 lang. And so on. So, simplifying, we have FBE equal to negative 60. Or simply, the force in member BE is 60 pounds and then nature niya is compression. And then lastly, for member CE, moment niya CE, sum up moments sa intersection sa duha, which is joint B. Simple ra, joint B, no? Okay. Ano lang, summation of moment at B, only have 3 forces, 1, 2, and 3. And CE is positive 1, 2, therefore, FCE is 1,200. Nature of force is tension. Okay, so yun na ang buhaton sa method of section. Dapat one equation, one unknown. Okay, so that's it. Thank you for watching. I hope you have learned something sa discussion. Thank you.